Welcome, ma'am.
Hello, good evening, ma. Good evening, everyone.
Good evening,
Thank you.
Welcome back, ma'am.
Thank you.
Yeah. Shall we start, ma'am?
Yes, we can start. Yes.
Yeah, okay. Mageshwari?
Education is not the learning of facts. It's it's rather the training of the minds to think. A warm good evening to one and all present here. I, on behalf of the Department of Computer Science, University of Madras and MHRD RUSA 2.0 Biomaterials team, welcome you all to 2 weeks workshop on analytical tools for image processing, day 11. We all had very useful and informative and interactive sessions for the past 10 days. Today's topic is dental image processing using deep neural networks. I request Dr. B. Lavanya ma'am, Principal Investigator, Biomaterials team, to say a few words about our resource person.
Ma'am, welcome, ma'am.
Yeah, thank you. Already, I think I got introduced.
Okay, ma'am. Okay, ma'am.
So let's go straight, right?
Okay, ma'am.
Thank you. Thanks for your courtesy. But however, we will just start the session.
Okay, ma'am.
Okay, thank you. So let me just share my PPT and then. And usually today the net is very slow.
Okay.
It takes a hell amount of time to get started.
Maybe
so how do you all do, the participants? Good evening, everyone. And I think it is a great pleasure to get connected to you all over again. And yeah, at last it has come. So yeah. So this is a kind of quite convenient time so that we can finish all the work, get settled, and then just listen to the sessions, right?
Yes, ma'am.
So
the
it's
participants
well
are teachers and research scholars. So we wanted them to really attend it. So
okay.
we fixed this.
Oh, great. Great. I think we just stopped with.
Yes, ma'am.
Yes.
Completed optimization.
Yes.
Yeah.
You just stopped with this.
Yes, ma'am. Yes,
yeah, well, in the last session, I was supposed to handle 2 sessions continuously, but due to some preoccupation, I was not able to handle the session yesterday. I thank all my thanks to the organizers for instantly helping me, and they came to my rescue, and then they just swapped 2 sessions and made it possible for me to get connected to you all over again today. Thank you, and on behalf of the participants, and I thank and congratulate the organizers for this wonderful endeavor. And let us move on to our session. In the last class, I just gave an introduction about the birth of artificial intelligence. Then we were discussing about what is the importance of artificial intelligence and what are its objectives and what best can be achieved out of artificial intelligence. And then we were talking about what is the purpose of deep learning and what is the difference does it make with respect to machine learning algorithms. And then we were discussing about how to train a model and what is data splitting, what is meant by training, what is validation, what is testing, what is meant by holdout, what are the percentage of holdouts that you can have, And then we were discussing about what is meant by overfitting, underfitting, and good fit, and how to measure whether a model is underfit or overfit or good fit. So all these things we were discussing. And then I just stopped with a few words about optimization. Now, I also added that the bias and variance play a very important role in any kind of artificial intelligence based methods, because only by looking into the bias and variance, we try to make some modifications, we try to fine tune the hyperparameters so that the accuracy becomes the maximum. There is some noise from the surrounding. So that becomes, please excuse me, just 1 minute, hold on. Well, and I was just making a mention about, sorry for the interruption. I was making a mention about bias and variance. Why bias and variance plays an important role? Because that is the one that makes us understand. Suppose if the variance is very high, what is the importance? If the bias is very high, what is the importance? If it is a combination of low and high, what is the high bias, low variance, high variance, low bias, low? And suppose if we have these kind of combinations, how to interpret their significance? How to interpret their influence on a model. See, if when you are writing a paper, when you can just make a mention or summarize or narrate on these aspects, that will be a value addition for your research article. So please do take care of all these things. And then, and normally we feel that because this artificial intelligence happens to be the hot cake, and this is the trending technology, we feel that anything that we do will qualify for a research work, a quality research work. The answer is a big no, because the models are readily available. We have very little to do on the model so that it becomes, we may be able to produce the results for, say, decision making or prediction or classification, identification, and things like that. So there is nothing great about taking a model, then fine tuning the hyperparameters, and then getting some higher accuracy. And your model must be optimized also, right? There are a kind of an array of optimization methods. Every day they are adding. So we should be familiar with the optimization methods. I'm just going to touch upon what is meant by optimization. And you please visit the blogs which are available on different types of optimization. And that will give you a greater insight into what is optimization, why it is important. Okay. So the goal is, so let us continue. So are you ready? And shall we move on? Dear participants? Okay.
Yes, madam, proceed.
Thank you, sir. Thank you. I think on the last session, it was 9, the number was around 95. Now it is 73. Hope others will join soon. Okay. So the goal is to hit the sweet spot of maximum value optimization, where foolish risk is balanced against excessive caution. And we must have seen, right? Just playing with treasure box. Sometimes they will take good amount of care and then they do some calculations, but still when they touch the box, that may have a very little value. So that is all about this. So optimization is a process of searching for parameters that maximize or minimize a function. So depending upon the type of function that we choose, it may have to be maximized or minimized. And if you talk about accuracy, precision, right, then it should be maximized. If you talk about error rate, then it should be MSE, then or cost function. It should be, MSE, if it is mean square error, it should be minimized. And if it is like accuracy or precision or recall, it should be maximized. So generally, MLDL, machine learning and deep learning models usually use indirect optimization. Certain metrics like accuracy, precision, and recall indicate how well a model solves a given problem. Naturally, right? It goes without saying, self-explanatory. So however, optimization with respect to relevant cost function, it is very specific to the problem, is a move. So whenever we talk about optimization, the optimization should be done problem specific, model specific. Otherwise, it will not serve its own purpose. So this is the first order optimization, and these algorithms minimize or maximize the loss function using its gradient value with respect to the parameters. You know what is a loss function, you know what is a cost function. You can just visit some websites on optimization, and this any model, the machine learning model or CNN model or deep learning model that you select, you can measure its performance with respect to its cost, with respect to its error, with respect to its loss function. So using its gradient value with respect to the parameters. So most widely used first order optimization algorithm is gradient descent. I think those who are familiar with artificial intelligence will be able to appreciate this gradient descent. See, when you start working on the given set of data with respect to some values, right? And suppose if we are talking about, say, cost function. So the cost function may be, say 40. So after some time, when you iterate, it may try to reduce. That is, there may be a downtrend. So it may just keep going. At some point of time, it may start increasing. So we have to find the appropriate weight that will give you the minimum cost, or it can be maximum accuracy. So now we have to identify the point. Which point will give us the maximum accuracy? So that's the purpose of this optimization algorithm. So the first order derivatives tell us whether the function is decreasing or increasing at a particular point. So then first order derivative basically give us a line in which tangential to the point on the error surface. Suppose if we have a kind of U-shaped curve, right? You can just draw a tangent, and then based upon the tangent, we have to decide how to reach the optimal value that we are looking for. So second order optimization algorithms, second order methods use the second order derivatives, which is also called Hessian to the minimum or maximum loss function. So, and this is another method that is for second order optimization. The Hessian is a matrix of second order partial derivatives. See, now you must be knowing, right? First order derivative, second order derivative. So the second order optimization algorithm will work on the second order derivatives of a given function. Second order derivative provides with a quadratic surface which touches the curvature of the error surface. So previously it is just a line, right, which is tangential to the surface. But now the second order derivative provides us with a quadratic surface which touches the curvature of the error surface, right? See, this is what I said. See, when we are doing the computation, we may have different kinds of, see, these kind of values. So you can take this as when you iterate many times, you may get a pattern like this. So this is called as local maxima, because this is the maximum value with respect to the entire thing. So this is the, you can just see here. Hope you are able to see here, right? And this is the local maximum, and this is one maximum, whereas the global maximum is this, because this is the point, right, where others cannot even come. Okay. Likewise, if you talk about minimum, this is one minimum and this is one minimum. Between these two, this is the maximum. So we call this as global minimum. now I just made a mention about gradient descent, right? So now we take, one second. Just a minute. Okay. Just a minute, I think the screen has gone. Can you see the slide?
No, ma'am.
No.
Your desktop is seen, ma'am.
Okay. Now, can you see now?
It's only the
Madam,
desktop.
desktop, madam.
Okay. What's happening?
The PPT is not opened or it's been closed somehow.
No, it is there. It is very much there. I don't know why. I'll share again. Taking this. No, is it? Is
Yeah.
it?
Yes,
Okay.
ma'am. Yes, ma'am. It's
Right.
seen.
Thank you. Thank you. Okay, so now we can see here, right? There is W. This is the weight that we assign for the parameters, and then yeah. Now we are going to find the cost function with respect to the weights that we have got, right? So what is your understanding about this? Now we are varying the weight from minimum to some value, some X value. So now what's happening here? Can you see here the curve that we have got? So what does it signify? This is what we call as gradient descent. What is gradient? That is the slope that we create. So there is a descent in the gradient. The gradient starts here and then it just descends down. Then it reaches at some point. We call this as J min W. This is the minimum value that we get for the given W, that is weight. This is, we call this as a global cost minimum. And after some point, this is the point of convergence where we can get the maximum accuracy or maximum precision. But now, you know, after some time, because we keep changing the value of W beyond its optimal value, what happens? And again, its cost is increasing. Okay, so we were talking about the tangent point, right? So we draw a tangent, we take a point, here. So this is the point from where the model is going to descend down towards the maximum, global maximum, right? So this is decided by the learning rate. So there is one component called learning rate in all the models. See, when the learning rate is very, if there's a bigger number, then the convergence will be very faster. We may not be able to understand or analyze the behavior of the model, right? And suppose if it is, for instance, say it's too small, then the speed with which it can descend down to this minimum will also be very slow. So we have to choose a value which is neither too small nor too big, so that the speed at which it descends down will be like ideally good. So we start from this point and then we just keep descending down, and this is the point where we have to reach. So this is what we call as the process of optimization. This is first order optimization, where we have this gradient descent. So gradient descent is an optimization algorithm which is mainly used to find the minimum of the functions. In machine learning, gradient descent is used to optimize the parameter in the model. So it can be maximization or minimization. The parameters may vary according to the algorithms, such as coefficient in linear regression, whereas it is weights in the neural network, because with respect to each model, it has got its own specifications. The inclined and or irregular is the cost function when it is plotted. Then the role of gradient descent is to provide a direction and velocity. That is, direction is whether it has to climb up or climb down. And here, it is descending down here. And then the learning rate is given as the velocity of the movement in order to attain the minimum of the function, where the cost has to be minimum naturally, right? So this is an example for what is the role of optimization in the model. In the case of first order derivative, we can always use this gradient descent. Okay. So it can be of different forms, like this is batch gradient descent, this is stochastic gradient descent, this is mini batch gradient descent. So depending upon the model and its features, it shows different kind of patterns. So then optimization technique, what is the purpose of this in DNN? Because this is a focus, right? To reduce the training error and the gap between the training error and the testing error. So it has got two objectives. One is it aims to reduce the training error. Second one is it tries to minimize the gap between the training errors and the learning errors. You must be knowing the training error. Suppose if it is not able to grasp the pattern correctly that is hidden in the data, it is a training error. And after it gets trained well, and if it is not able to grasp the pattern that is present in the unknown data, that is testing error. So learning rate is a hyperparameter that controls the movement against the gradient in each iteration of the algorithm. So then in the floating point value, it is a floating point value that makes the proportion of weights update. So it is learning rate should be always 0.1, or it can be 0.2, 0.4. And accordingly, and whenever it descends down, and the weight is also accordingly getting changed. So the other possible optimizers that you can use is the ADAMS, right? Adaptive Movement Estimation Based Model. Then RMS prop, where RMS stands for root mean square propagation. Then ADA grad is adaptive gradient. Then ADA delta is adaptive delta. Then SGD, stochastic gradient descent. These are only suggestive. There are a good number of optimizations available. So then one thing first, when you start with your process, then you have to start with, just a minute.
Ma'am, your voice is not audible. Ma'am, are you there, ma'am? Professor, are you there? Oh, she has muted her. Maybe she's unmuted.
Yeah, no, I have muted myself because there was an important call so from the university. So right.
Okay, ma'am.
Okay, I'm sorry for the interruption. Okay, so first we focused on bias and variance, then we have to focus on optimization. Now we have to just go ahead with the evaluation metrics. So this evaluation metrics play a very important role, and we must know what is the significance of accuracy, what is the significance of precision, recall, sensitivity, F1 score, F measure. All these things should be first of all understood by the researcher, right? So you have to just see what is the relationship between the accuracy and F1 square, accuracy and sensitivity, accuracy and precision, right? So now when you are writing your interpretation, you have to put your mind together and then try to see how these values, but normally when you go for this kind of accuracy, and we have to have that confusion matrix. which has got true positive, true negative, false positive, false negative. I think every one of you must be aware of that. So from that, we have to select the value and then go for this kind of computation. And here, for instance, when you want to go for accuracy computation, it is number of correct predictions that is done by the model divided by total number of predictions. Very simple. We have 100 observations, 100 records. And suppose for 50 records, my model predicts correctly, then it is 50 by 100, it is 50%. Accuracy is a very direct kind of computation. And when you go for precision, then recall, sensitivity, then we have to be all the more careful. So it works well only if there are equal number of samples belonging to each class. See, what is meant by a class? The class is the output value, right? Now, suppose if I have 100 data, and suppose if it is COVID identification or prediction, and if it is present, then the value must be 1, or if it is not present, if it is COVID positive, it should be 1. If it is COVID negative, it should be 0, for instance. If I have 100 data, then it should be 50-50. That is, I should have a record which will have zeros, right? There should be 50 such records. Likewise, I have to have 50 records which will have their value as 1. So this is what you mean by it works well only if there are equal number of samples belonging to each class. Suppose if I have 4 such classes, right? 1, 2, 3, 4. And then I have to have 25, 25, 25, 25. That is the distribution of these class values should be uniform. Otherwise, the model will not be able to understand the pattern, so that it gets biased over the data. Am I clear to you regarding this point? So this is all our confusion matrix. I do not know why they have coined this terminology, confusion matrix, but this is always confusing. So this is the actual class values, right? And suppose when I have the record may have the corresponding values, positive and negative. And this is the predicted class, positive and negative. So, and in this case, here, true positive, we have to compute how many correct values are being predicted as correct. And this is positive, right? Suppose if it is COVID positive, then the model has predicted this is wrong. So we call this as false negative. It is not negative, but this is the negative which is given by the model. So it is false negative, right? And suppose if there are certain things as a negative, right? There is COVID negative, but the model has predicted as positive, and that is not true positive. So it is called as false positive, right? And in the actual class, it is negative, and in the predicted class, it is negative. It is called as true negative. So if you can understand these two things, right, then it is very easy for us to go for interpretation. So this is called as type 2 error, and this is called as type 1 error. You can even write a paper on this, right? How you can understand these values and how to interpret these values when you get them for your model. So you can, I think one of the participants had sent a message in the chat box to share this PPT, and definitely I'll do it at the end of the session. After I finish, I'll pass it on to the organizers. They will be able to share this. So this is how we have to compute sensitivity, specificity, accuracy. Then see, accuracy was computed as number of correct predictions, right? So what are the correct predictions? Here it is a correct prediction, and this is again a correct prediction. So we take true positive plus true negative divided by all put together, right? Because as you add, suppose if I have 100 records in the confusion matrix, when I add all the 4 quadrants values, that will be equal to 100. So it is 30, say this is 40, 70, then it can be 20, it can be 10, all put together, it is 100. So total positive plus total negative plus false negative plus false positive, all put together will give you the total number. So it is correct predictions divided by total number of correct predictions divided by total number of predictions made. So it has done the prediction for all the 100. So it is total number of predictions. So a confusion matrix is an n cross n matrix where n is the number of classes being predicted. So the accuracy is the proportion of the total number of predictions that were correctly predicted. Then positive predictive value, or we can call it as a prediction, the proportion of positive cases that are correctly identified. A negative predictive value is the proportion of negative cases which are correctly identified. And sensitivity or recall is the proportion of actual positive cases which are correctly identified. Then specificity is the proportion of actual negative cases which are correctly identified. So you don't have to worry much because the model will give you these values, but we have to understand how it is calculated, which value is making the model to exhibit the right kind of prediction. So you have to focus on the respective metrics, and then from the metrics, we must be able to explain or describe or summarize the behavior of your model. So then you can make use of this true positive rate recall on sensitivity, then true negative rate specificity, then Dice coefficient, that is the metric measured between two samples, then accuracy, already we have seen, precision, F score, all these things, right? We must be familiar with. And of course, you have got, if you have the confusion metrics in hand, you have got ready-made calculators available. If you can just feed, it will give all the values. Okay, so let us move on to CNN. So the CNN is the basis for us to understand how this deep learning works. So that's the reason why we have just started with the CNN. And this is, as I have already made a mention about what is meant by a neural network. It has got a set of nodes in the input layer, and you may have one or more layers in the hidden layer, and then we have got the output. So suppose if you imagine there is going to be a neural network sitting here, and I just want to classify the given image into, say, apple or orange or pineapple or banana or whatever it is. So now this model is going to make use of the texture, because texture is an important component with respect to an apple or an orange or even pineapple. And then its color, then shape, as well as size. Right? By using what do we call these things as, dear participants? What do we call these as, this texture, color, shape, size, as precisely in terms of our machine learning terminology? What do we call them as?
Features, madam.
Sir?
Different features, madam.
Exactly, sir. So this is what we call as features, right? And we may have a data where there may be hundreds of features, but for fine-tuning a model, we don't have to take all the 100 features. Instead, even we can optimize the feature selection. That may be again another paper. There are different methods like co-occurrence matrix, then principal component analysis, and variants of principal component analysis. So we can apply these kind of algorithms and try to select, handpick the best features which may be helpful to us at the time of prediction or classification. So it is texture, color, shape, and size. These are the features. So just to illustrate, we have taken 4 features, and the number of features can be even many more, right? So the model will read the input, then it takes different textures, and the textures are being used by the model to go for prediction, whether it is an apple or orange or a pineapple. So this is about CNN, and these are the different phases of problem solving using CNN. So convolution is a pointwise multiplication of 2 functions to produce the third function. So this is a very simple statement that will make us understand how the convolution neural network really works. So when you have an image like this, we are going to make use of a filter. So this filter, you may have a set of values here, which are arranged in the form of rows and columns. So here also you are going to have an image, which is a combination of pixels, and each pixel will have its own intensity. So in such cases, we are going to superimpose this filter over the image. And suppose if the image is, say, 100 cross 100, then I can have a filter of size 3 cross 3. I'm going to, embed my 3x3 over this place, and then we are just going to do the pointwise multiplication. If I take 0, 0, 0, 1, 0, 2, then 1, 0, 1, 1, 1, 2, then 2, 0, 2, 1, 2, 2. I'm going to take these coordinates from the filter as well as from the image. Then I'm going to go for pointwise multiplication. So primary purpose of convolution in CNN is to extract the features from the input image. So now we have to extract the features. Suppose if I want to write a model to identify this bird, then I have to extract the feature, how the eye looks like, how this beak looks like, how the neck looks like. So I just want to extract the identities of an image so that it is easy for the model to go for prediction or classification or identification. The matrix formed by sliding the filter over the image and computing a dot product is called as convolved features or activation map or feature map. And you just take it this way. We take the image, we apply the convolution operation. After that, we have certain features of the image. Because we have taken the features, it is called as convolved feature. It can be the eye shape or it can be the beak shape. And because we have extracted feature using the process of convolution, we call this as convolved feature, or it can be activation map, or it is called as feature map. So what is being done here? We have taken the image, we apply convolution operation, and after that we have to apply a process called activation function. That is what we call as ReLU mapping, and then we perform an operation called pooling. What is the purpose of pooling? We try to even refine the features we have got so that we can just do away with unwanted pixels of this image so that it becomes highly intact for the process of decision making or classification. See, this is the input image. This is the convolution filter. And then we do the operation. Then after applying the activation function, we go for max pooling. And you can see here, by applying this filter, the size of or the number of pixels that represent the feature of the input image will be very, very less. And after that, after you finish with pooling, now we have to go for vectorization of the features that we have got. And after vectorization, what is vectorization? If the features extracted from the image are in the form of two-dimensional matrix, then we have to convert it into one-dimensional matrix. So it is shown this way. And then we just go for fully connected layer. CNN comes into play. Then we just go for some classification. So now let us just move here. The convolutional neural networks have the following layers. First thing is convolution layer, and then it is with striding. What is striding? The fashion in which we move the filter. Are we going to do the hopping by one row, one column, or 3 rows, 3 column? So this is striding. Then padding is whenever we are applying this convolution operation, naturally after convolution, the output of convolution operation, the size of the matrix that you get as the output after convolution operation will be lesser. In the sense, whenever we apply convolution operation, it leads to dimensionality reduction. What is dimensionality reduction? When I have an image of size 50 cross 50, after I apply the convolution operation, you are going to get a dimension which is much lesser than your 50. Okay, so you can repeat this operation any number of times. Every time that leads to a dimensionality reduction. What is the need for us to go for dimensionality reduction in CNN? What is the necessity? Well, why should we apply this convolution operation, extract the features, and achieve dimensionality reduction?
To maximize the accuracy.
Sorry?
To maximize the accuracy of classification.
It is partly correct.
time can be minimized.
Sorry,
Training time can be minimized.
that is also true. That you
For feature extraction,
yeah, we are doing feature extraction.
yes.
And why not we give the image directly? Why should we give Manga? Why should we give this in the sense? Why should we extract the features and give this to the neural network? Of course, it reduces time, and of course, it reduces the computational complexity. And beyond that, there is another component that we have to be conscious about. See, when you're constructing this neural network, when I have an image of size 100 cross 100 or 10 cross 10, I have to have 100 input nodes, right? Yes, no, it's not training model size. I'll put it this way. And suppose when I have an image of size 10 cross 10, what happens is I have to have 100 input node. You can just imagine constructing an NNN with 100, it will be too complex. So we want to construct a CNN or neural network with the possible minimum complexity. So when I have 10 cross 10, when I go for the actual features, right? Yeah, that is also correct. The background image, which is not needed for our training, will be neglected. Yes, of course, right? We will be just removing the unwanted information, and we just extract only the features. So now when we just do this way, when I have 10 cross 10, which contains 100 pixels, I may be ending up with say 5 cross 5, or it may be just say 5 cross 10. Then what happens if it is 5 cross 10, then it is only 50. So we are reducing the complexity of the network by 50%. Now what happens is any kind of, this is the logic. See, we take the input image, we apply convolution operation. That convolution operation is going to lead to dimensionality reduction, and that dimensionality reduction will help us to have a neural network which is having less complexity. So that is the whole idea, right? Well, so this is what I wanted to just highlight. So we do the convolution, then the next one is padding. Now, we know pretty well when we apply convolution operation, naturally the size will get reduced. See, now when I want to retain the size as such, I don't want to reduce the size of the input image. In such occasions, what do? We just add zeros at the on top, then bottom, left, right. So naturally it becomes easy for the programmer to retain the size. So the original size of the image will be retained. So that is the purpose of padding, right? Normally we do zero padding. Then this is ReLU layer. This is the layer for activation function. And we can use any kind of activation function depending upon a requirement. Then pooling, as I told you, from the extracted features, we try to refine the features by going for max pooling and min pooling. Then fully connected, this is fully connected. So each node is connected to another one. It can be in the hidden layer. From hidden layer, there may be a layer to the output. So this is pooling, max pooling, min pooling, fully connected. This is a fully connected. So the output of the fully connected CNN will be the actual result that we are looking for from the model. It's the input image. So we perform convolution and ReLU. Now this can be done any number of times. So it can be one time, or it can be many times. And after that, what happens? Then we go for max pooling. So max pooling will further reduce the size. And then I can even go on for any number of times. I can repeat this for any number of times. When you're well, and after that, whatever we get out of this operation will be given to the fully connected layer. Then depending upon the model, it can be just forward propagation. If it is from the neural network to the output, it is forward propagation. And if it is going to be from the output to, after getting the output, again, you go back and then fine tune the input variables. We call it as back propagation. So CNN is composed of stacking of several building blocks: convolution layer, pooling layer, then fully connected layer. A model's performance under particular kernel and weights is calculated with the loss function through the forward propagation on the training data set, and the learnable parameters like kernels, weights, and then updated according to the loss value through back propagation with grade. Now we can apply gradient descent, right? We just want to go back and then find the typical optimized value. Okay. So the selection of number of kernel or filter. What is kernel? This is, suppose if I first choose 5 cross 5 as the, please remember, this is what you do as convolution operation, convolutional filter. If I choose 5 cross 5 now, I can go for 3 cross 3. Or if I choose, say, 11 cross 11, I can use 5 cross 5 next time. So that is what you call as kernel. So the selection of a number of kernel and then filter, kernel, filter, mask, convolution, and filter, everything refers to the same thing. It determines the number of feature maps, activation output produced by the convolution. So this is how the convolution operation will go on. So the image is taken, it is read, then the size is reduced, then output is being produced. So quickly, let us go through this. CNN learns the filter automatically without mentioning it explicitly. These filters help in extracting the right and relevant handouts, handcrafted features from the input data, and now to overcome the curse of dimensionality in neural network, when it becomes too high in terms of dimension. If it is a high resolution image, then the number of pixels will be more. So then it will make the system complicated. So for that purpose, to overcome the curse of dimensionality in a neural network, when it becomes too complicated to handle a high resolution image.
Excuse me, madam. I'm having one question, madam.
Was there a question?
Yes, madam.
Yes.
Madam, how the number of features is related to the number of filters?
Number of pictures, what do you mean?
Features.
Features. See, you must be knowing about Privet, Sobel filters, right?
Yeah.
Yes. So we have to select a convolutional filter which can extract the features in the horizontal direction or vertical direction or in the diagonal direction, and then we have to combine them together later. See, when I want to know how to make a model to understand A, right? So I must be able to extract A, which is a slanting forward, slanting backward, then a middle one, which is in the horizontal shape. So I should have a filter, then otherwise I have to change the filter pattern. So I'm talking about the size, dimension. In the dimension is the size of the filter. In addition to that, there is another component called how the pixels are being organized, how the zero intensities, how they are being organized, non-zero, how they are being organized. Right? So only the pattern that you give in the form of filter will help us to extract the features.
Okay, number of filter is not affected by the number of features.
Pardon me, sir?
Number of filter is not affected by the number of filters.
Yes, of course. If you want to extract some 10 features, we have, because each filter that you use is going to have a specific pattern.
Okay.
To extract a horizontal information or vertical information or diagonal information or circular information or a triangular information, whatever that you want to extract.
Okay. If there are 10 extracted feature, then how many will be the filter?
Pardon?
If there will be 10 extracted feature,
Yeah.
then how many filter will be
If
used?
they are not interrelated, if they are exclusive, necessarily we have to use 10 such filters, sir.
Okay. Okay. Thank you.
I think I must be having an example. Yes, I have an example, so you will be able to understand. Shall we just finish the example and then clarify your doubts, please?
Okay, madam. Continue. Madam.
Okay, sir. Okay, thank you. So overcome the curse of dimensionality in a neural network when it comes to neural network, right? And when the dimension is very high, then the number of pixels to be handled will also be very high. So CNN captures the spatial features from an image. Spatial features refer to arrangement of pixels and the relationship between them in an image. So they help us in identifying the object accurately in the location of an object, as well as its relation with other objects in an image. See, now there should be some correlation between one feature and another feature. So the filter that you design must be able to cull out those kind of details or features from the given image. So CNN also follows the concept of parameter sharing. A single filter is applied across the different parts of an input image to produce the feature map. See, now this, suppose this is filter number, kernel number 1. So this filter will be used for handling all the pixels present in this image. And after that, I take another filter and then start working. Right? So a single filter is applied across the different parts of an image to extract similar such features. So here, the input image, we do the convolutional layer. Then this can involve striding or padding. And then you have this ReLU layer, that is activation function, which can convert the intermediate values from which the model cannot get any information into a form, into an understandable form. So then pooling is max pooling or min pooling, then fully connected. So these are all the layers, right? Now let me take this. See, A, B, C, D, E, F, G, H, I, J, K, L. I have an input of size 4x3. Now I have a keyword of W, X, Y, Z. So we have to know what is point-wise multiplication. So now, out of this A cross 8, right? We just take only 2 cross 2 and then try to find the point-wise multiplication. Then you take the next one, do this, and then just find how things are working, right? So for this, it is A into W, it is B into X, then it is E into Y plus F into Z. So like this, we have to move this to the next position, and then we have to go for computing. See now. See, this is how we have to move. If I have an image of size, say 5x5, and if the filter size is 3x3, I get the output image of size 3x3. This is the formula that will help you to understand. And for simple understanding, I'll explain for this alone. So what is the output height and what is the output width? Height means number of rows, width means number of columns, right? So if I have this of size 5 and this filter is of size 3, right? Then I can apply here, I can apply IH, that is 5, minus 3, 2, plus 1, 3. Again, width is 5 minus 3, that is, this is the width of this filter, plus 1. So I get 3x3, output or feature map, output width, output height and output width. So striding is the number of pixels shift over the entire input image. So now this is how we do striding, right? So this is what you call as striding. So depending upon the striding pattern that we choose, accordingly the size will be reduced. See, for the previous one, for the striding is equal to 1. This was, it was 3, right? Here we change the pattern of striding. It becomes 2 cross 2. So that's another formula for this. So padding is 0 padding. So it's the original image, we have added zeros. So we perform 3 cross 3. So once this is done, then all these values will get entered. Okay. So pooling layer, we can see here what is meant by pooling. Now, suppose if I take say 3 cross 3, if the value is maximum from this 3 rows, 3 columns, I have to take 2 and the 2 is given. The next one is 2, 0, 1, 0, 1, 1, 1, 1, 0. Again, we have taken this 2. So like this, we have to do the filling, and how to calculate the output size after the pooling layer is given with this example. Okay, so fully connected dense layer is the one where we extract the features and give it for processing. So neurons in this layer are being used to have a fully connectivity with all neurons in the preceding and the succeeding layers, and it just does the matrix manipulation, right? It is used to map the representation of the input as well as output. It can be followed by convolution layer, pooling layer, and you can just, Google on all these things and try to get as much as information possible if you are a fresher. Otherwise, it is just a child's play, because the model is there. Metrics, it is just a child's play. We can just go on and on and on. So these are the famous CNN, LeeNet, AlexNet, ZFNet, Google Net, then BGGNet, ResNet, Inception, MobileNet. This is just examples. Okay, so now let us get into our main business. DL for dental images. Now, images are the primary tool for diagnosis in healthcare sector, and deep learning can play a prominent role in the analysis of dental images. Using computer to analyze the medical data is known as computer-aided diagnosis. So deep learning algorithm can also help us to classify as well as predict any kind of disorder or ailment or any complication. So deep learning is the in dentistry for dental images analysis is playing an excellent role to find out the condition of the teeth, helping the doctors to recommend the appropriate treatment. So dental radiograph in dentistry can help dental practitioners to diagnose numerous oral as well as maxillofacial diseases. Though then radiographs are often difficult to read and present the number of challenges to dentists and the diagnosticians when determining the abnormalities. So most commonly used radiography technique is OPG, orthophantomography, and this panoramic or wide view of X-ray of the lower face, which displays all the teeth of the upper as well as lower jaw or in a single film. I think all of us must have seen that. So the types of dental radiography are intraoral, then extraoral. An X-ray film is kept in the mouth to capture the X-ray picture, and which comprises of all specific details about the teeth arrangement, tooth canal. If you want to go for root canal treatment, how the root is, how far it has gone in, all those things can be done. This can be used for treating the root canal infection as well as to identify the caries. So extraoral radiography is like normal kind of X-ray taken. You just mount the film somewhere away and then send the X-rays, get it reflected, and then take the footage. The dental imaging modalities are intraoral, extraoral, and here it is periapial X-rays, then bedeaving X-ray, then occlusal X-ray. These are all the examples of intraoral. As we go for this extra, this is panoramic. I think with all the experience of having handled our camera and then our mobile phone camera, we know what is panoramic, right? That is wide angle. Then cone beam CT, then cephalometric X-ray, then xylogram. These are all just examples. So when you want to really explore on dental images with respect to any deep neural network or any kind of network, we can just try to explore these kind of data sets and then see how the algorithm is working. So AI technology in dentistry. Now this dentistry is no exception for artificial intelligence because it is a kind of a giant which has taken everything into its hand. So AI is the latest trending technology which is probably going to be massively affect the dental consideration as indicated by the healthcare technology specialist. AI revolution in dentistry will depend on deep learning and then training utilizing the past information. So as it is accepted that the section of AI technology can acquaint few creative ways with the clinicians as well as to prepare them to give better dental care as well as dental care to the patients. So from the effective communication, ideal booking of patients to giving increasingly informed and quality diagnosis, AI will help to improve the quality of dental considerations with its various applications because this is going to really complement or this is going to augment the understanding about such images. So it is needless to mention that this is a kind of boom. So suppose if you have this kind of image, input image, we can perform pre-processing, we can go for segmentation of a particular image, a tooth that we want, then we can go for feature extraction, then classification, whether it is the tooth is decayed or whether it needs treatment or not. So, so any one of this can be a good area to research. It can be pre-processing where we deal with noise reduction, then enhancement or segmentation or just extracting the feature, then go for classification. Excuse me. So now when we talk about this deep learning, we don't have to go for hand extracted features. Everything happens spontaneously. The traditional model used for dental image segmentation and classification, we have to go for human identification or it can be bone loss. Suppose if there is a gap, or it can be caries detection or computer guided treatment. Suppose if you want to go for implants, right, where you want to replace them with the suitable replacements. So how it can be done, what is the space available, how we can fit in. Then assist or a tumor extraction, or it can be root canal treatment diagnosis. So in all such cases, right, we have to go for image segmentation. So what are the problems in dental image segmentation? Number one, poor image quality due to the presence of some noise, or it can be like irregular shape of the object. Suppose if the shape of the object is not helping us to converge to the segmentation, or intensity variation in the X-ray. Suppose if it is a little blurred and if it is not having good contrast as well as brightness, then it is going to be a problem for segmentation. And proper selection of typical method for the application. We have to choose the appropriate method. It can be quadri or you can go for watermarking. What kind of model are you choosing for segmentation also matters. And the limitations of the capturing device. So each and every device may have its own operational limitation. So that may also impact on the quality of the image, which will again impinge the quality of segmentation. Then a lack of availability of data set. This is again a big headache. So please try to understand each one of this is a challenge. Each one of this is a research gap with the support of which you can proceed further. Suppose if there is no data set, we can go for creating the data set with the support of the dentist. And each one is a challenge. Whenever you have a problem, the problem should be changed into our opportunity. And what is the difference between, how do you differentiate optimist and pessimist? Because when we talked about problem, I thought I'd just talk about this. What is the difference between optimist and pessimist? Any one of you? You can probably unmute your mic and then talk to break the monotony. See, optimist is the one who can find solution for every problem, and pessimist is the one who finds problem in every solution, right? So when I said if each one is a problem, we can just think of developing algorithms to handle all these things. Okay. So dental image processing step one, collect attachments or X-ray of different formats and media. It can be DICOM X-ray or it can be a PDF or it can be JPEG as we have. Then annotate specific image characteristics and feature example. peripheral radioluminescence, and there is a bone loss, right? Suppose if there is something is missing here, it's a bone loss. So what is meant by annotation? Now, the model will be able to read, or as we have human visual perception, the model will be able to look into the image. It may identify the features which may get converted into a summary. So we can do the annotation. So for each and every image, it is going to give you a kind of suggestion. What is the problem with a given image? And then step 3, train all AI models on this labeled data so that they can identify that. Then we have to go for training, right? There are going to be multiple such images, then the model will be able to understand. Then run the trained AI model on the new image and calibrate based on the desired performance as well as relevance. So example, a trade-off between the precision and recall, right? You know what is precision, what is recall, we get all those things and then try to adjust the model so that it becomes easier. So steps for diagnosing this dental diseases, and development and research are classifier, that is the model. Database and the application would be deployed on the web for everyone to use. We can go for that. Our research would be conducted to determine the accuracy and precision of our classifier. So this is the final one, right? So let me just start with data acquisition. So we start with this one and then we have to reach this point. What is data acquisition? Capturing the image. So collecting the data set of any kind of image, it can be panoramic or it can be any format as we desire, collect the data. And then data cleaning. Suppose if it contains some noise or if there are some artifacts, unwanted information. One of our friends made a mention about when you go for feature extraction, it eliminates the background details. Like this, if there is information about name of the patient, then the date of birth, then all those stuff, those things can be removed. Then the scanning center name, if they are there, they can, we just call them as removing the artifacts. So screening, you can remove noise, you can remove such kind of things, and then we can go ahead with improving the contrast and brightness, that is image enhancement, that can be done. Then as we discussed, we can go for segmentation. Segmentation is segmenting ROI. ROI stands for region of interest. Suppose if my concern is only the root, then I have to segment this portion. If my concern is about the enamel, then I have to use this particular layer. And if it is depending upon the researcher's interest, depending upon the researcher's objective, we should go in for this kind of, right? So our aim should be extracting the region of interest, and then we go for data labeling. Suppose if there is a tooth loss, or if it is it has caries, if the root is damaged, then we can just give a labeling, right? And then we go for, once the labeling is being done, then we can go for training as well as testing. So training is being done, then we can test whether the model is working well or not. If it is perfect, we go for deployment and research, because every research will have scope for future enhancement, that we can just keep working on it to get better results. So semantic segmentation is used for detection and classification as well as segmentation of teeth, right, in the given image. So the neural network architecture for object segmentation, it can be, as you know, right, input image, you have to go for, now in the case of deep neural network, instead of using this kind of filters, we call them as encoder convolution neural network, right? So convolution plus ReLU. This is what we have seen earlier. And then we go for pooling, right? Then after pooling, it gets reduced. Now we have got this these details. Now these details are going to be given to softmax, that is the one that is going to help us for classification. So then we can just see here. One second. Yeah. See now we can see here there are some instances of segmentation. Can you see here? There is a bounding box which is drawn with respect to each and every image, right? So like this, we can identify, we can just count if there is a kind of some problem, we can count how many teeth are present and after it falls for some reason, and all those things, right? So our understanding is input layer, then it performs using encoder, the convolution operation, and then next one is and there is encoder, of course, there should be a decoder, right? Encoder, decoder, auto encoder we call. So encoding and decoding will be done automatically. And then pooling is done, then pooling indices are to be given to this. And then there is the entire pooling operation will be taken care by means of this auto encoder. Then it has to be translated to make the model understand. Okay, everything happens automatically. Then semantic segmentation, because when we talk about segmentation of a particular tooth, which can be again magnified and then further processed, so that can be done. So this is an example for segmentation. Then workflow of dental image, and here you have this caries detection, for instance, right? So we have taken beteaving radiograph, then tooth segmentation can be done, right? Then caries can be identified. Now here there's a label, right? We have noted this point. So this is the place. This is what you call as region of interest, right? And I mean, if I want to focus only on this particular teeth, so this is my region of interest. Okay, then we can go for annotation. Then caries detection, then tooth structure is restored. So how do we do here? Image data is being taken, right? We may have multiple such images. Then we just decide what is the epoch, how many number of times it should be iterated. So here comes your fully connected layer. Then this is forward path. Then we go for prediction. Then we check what is the error, and then we just go for backward propagation. This continues. So DL research in dental field, it can be used for prosthodontics, then periodontology, orthodontics. I'm not having much knowledge about all these things, but at the time of preparing, it is necessary, right? So I have just taken, because each one can help the participants to just go for it. So orthodontics, then oral surgery, oral medicine, charting, forensic dentistry, right? Endodontics, then dental radiology, cardiology. Each one is an opportunity for us. We can work happily. Then we can go for the development of applications. I was in fact, informed by the organizers to give a kind of demo. But unfortunately, during the online, it doesn't really work. So I was not able to, show any demo. However, I think I'll be able to share some slides later. I will share few slides that contain the code as such as well as the output, right? And due to paucity of time, I was not able to prepare it. However, I'll try to pass it on to the coordinators. You can just use that code as the starting point, because you can just implement and then start sharing, and that will be a kind of good to start with. Like, instead of just meddling on your own, you can just have some hands-on on that and then try to see how best we can proceed further from there on. So applications of deep learning in dentistry for any kind of radiograph image we can use. In the case of beteaving radiograph, smart scheduling or smart patient communication. Suppose if you want to pass this information, right, meticulously, that can also be done. If it is telemedicine, if the specialist is not available in the place, then you can just send it over the phone, and then you can just use it. You can get the expert opinion and then go ahead. Okay, so online dentistry is, you can go for mobile app. See, whatever that you do can be converted into a mobile app. Those who are familiar with MATLAB must be knowing there is a guide tool library available, with the support of which our program can be easily converted into an executable one. Or we can go for even developing a special software which can operate on the mobile platform. Then we can think of dental chatbot, right? A dental chatbot is fun and accessible means of patients to have any answers to their questions. And then they can simply ask a question by sending message instead of scrolling through multiple pages of dental website, right? It can be just an assistant, a virtual voice assistant. And then a chat box will reply to the patient in an instant. So they can get the best answer regarding to the dental related questions. Suppose if they have some questions in their mind, they can as well just go ahead and get them clarified. So benefits of AA chatbot, you can motivate the faculty members can motivate your students to work on this chatbot. Then it increases the number of patients that are that are sitting for appointment, and then you can think of whether it is going to be online, if is it round the clock, round the year, like that. So depending upon that, you can just make use of the availability. Then it can entertain a lot of clients at the same time, right? That is the best advantage. Then it can help in saving the money as well, right? Like you don't have to just run from pillar to post. You can just talk to chatbot. It will be able to say offline or through online. Okay. So this is periodontal disease, right? Depth probing. We just want to see how far it has gone. So that can also be identified. And then this is just taken from the web, and that can be identified. You can see here, right? For each one, there is a label. So the labeling is being done, and you can just take this image as such, do the labeling, and whatever be the operation that you want to do, you can as well do. So this annotated dental data, right? So we have given annotation, a detection diagnosis of dental caries, right? How dental caries are present. Now you can just take the panoramic view of the entire jaw, and then try to see how many teeth are infected with the caries and how many teeth are not infected. That can be done. Each one is being labeled, right? Some of the results, outputs of the disease detection. So whatever be the model that you have, and that can be performed this way. I'll try to share the simple coding, right, for you to start with. See here, we have with the bounding box, we have identified the area, and then this is another example. This is yet another example. So this is how we have to go ahead with research, and then research in dentistry. Now, this is a very interesting topic. There is less amount of research being done in dentistry. So those who are interested to work with artificial intelligence can explore its potential on dentistry and try to come out with new research articles. So the takeaway point is, first of all, when you want to work with artificial intelligence, you should know the essentials of artificial intelligence, especially basics of statistics as well as probability and the essentials of mathematics, right? Because each model has got its own characteristics. So the one that gives 98% need not work better on some other problem domain. So number one, we have to choose the correct model. And how do we decide on the correct model? That can be done only through trial and error, right? We have to just go in for trial and error, and based on which only we can take a decision whether the model is working or not. That is the reason why when you want to work with machine learning, you have to explore all possible algorithms. Say you can start with linear regression, you can go for logistic regression, decision tree, then support vector machine, then Bayesian classifier, all these things should be explored. Then you just tabulate all your values, accuracy, precision, recall, bias, variance, everything. And then you try to identify a model which is suitable for you. Okay, so then number one. So we have to explore and then take the model. Then if suppose if the support vector machine is working well, then we have to go for optimization. We have to go for hyperparameter tuning, and then you have to ensure that the model is working well. So once the model is working well, then you have to see with respect to the other evaluation parameters. So once everything is working perfectly, you have to apply optimization. Then you can set the target as 98% of accuracy. Then you can do. And if you feel that at the time of doing this optimization or fine tuning, if you hit upon an idea which is very novel, and I just encourage you to immediately go in for filing a patent. Okay, so you just patent your paper, try to file your papers, and then probably that will really help you, right? And so it should not be like just taking a model and then experimenting. And there are a lot of things to go into it. That's the reason why I'm telling all this. So if you can just follow all these things, right? Follow the steps, right? You may be able to just go ahead and then get things done, and you can get good results which can get communicated to SCA journals and journals with good impact factor. So ensure it has some novelty, and please don't replicate others' work. Replicate others' work to understand the problem, but please do not just give it as such. So give your mind, give your thought, and then try to do it. I think for most people, sky is the limit, but those who love aviation, sky is the hope. So we should be inspired, and we should have a lot of motivation to work on this domain, and that will really help us to, right? So good luck to you all, and I'm done with my presentation.
Yes, ma'am. Thank you. Thank you so much.
Yep.
There's one question, how to annotate images?
And there is a mechanism for that. And one way is you can just take the image and do manual annotation. For that also there is a mechanism. And if you want to automate it, you have to identify what type of thing is present, and then objectively you have to go for it. Because when you want to populate your data, annotation is a very important thing.
Is there any specific software? That's another question.
Software, no, it should be part of your machine learning method. And if there is a hands-on experience, we can just, demonstrate and show you how annotation is being done. But anyway, I'll try to share some information on this annotation sooner. Because this annotation becomes a part of your exercise when you go for training. Because on some cases, you may not have good dental data set. In such cases, we have to create the data set, annotate the data set, then you have to go for training and testing, evaluation and everything.
If we are creating a real-time data set,
yes,
how can we justify it, ma'am?
See, you have to have the opinion of physicians. Suppose if you are developing a data set on dentistry, then you have to do it in coordination with dentists. If it is on agriculture, you have to get the expert opinion of the agricultural scientist. If it is on animal husbandry, then you have to take into the take into confidence their cooperation. Actually, and if you can develop a data set, you can just Google for such papers. If you develop a data set, that itself will give basis for writing a very good research article.
Participants, any other questions?
Ma'am?
Yes.
One more
will the deep learning network, as you are saying, always performs better? If I try the support vector machine or any other such classification method, will
See,
it,
this is another option, right? And there is no assurance depending upon the data distribution. The accuracy is going to vary. So there is no assurance that for each and every problem, artificial intelligence is the ideal solution.
Thank you, ma'am.
Yes,
there's
because there
one
is no assurance. Because sometimes you may have a student who is number one. Sometimes the student may utterly fail on some other subject. The one who gets 100% in mathematics need not score 100% in science also. So it all depends on how the brain works. The same thing applies for artificial intelligence models also.
Okay, ma'am. On trial and base, our classifiers works.
Yes, first of all, you have to validate whether your data set is suitable for artificial intelligence. That's why I said just experiment with everything. If the answer is convincing, then you can go for exploring it further.
There's one
Ma'am,
more
thank you,
question, ma'am. Which learning method is best for dental treatment in implant technique?
Learning method. What do you mean by learning method?
Learning method is best. Which learning method is best for dental treatment in implant technique?
Yeah, I'm reading the question.
Okay, okay.
Actually, there is a component called learning rate.
Maybe the participant can unmute and ask the question. like,
Yes.
what is in her mind?
Yes.
Supervised or unsupervised seems.
Oh, okay. See, the point is very simple. If you have annotated data, you have to go for supervised. And unsupervised, as you all must be knowing, it is used only for clustering, association, as well as relationship association mining. And if you want to go for classification, etc., you have to train the model and then you have to go for supervised learning, for which you have to have annotated data. What is annotated data? Data with both input parameters and output parameters.
There's one more question. If there are 100 extracted features, how many input-output nodes and filter are required?
If there are 100 extracted features that you want to use in your model, there should be 100 nodes. An output node is going to be your classification. How do you want to classify? Whether it has carry or whether it has some bone loss, that should be decided by your classification pattern. And in between, the number of hidden layers that you use depends on ultimately your model, your convolutional CNN model.
Okay, madam, input will be 100, I think. You have already discussed.
Here input is 100. It will be very tedious. You should not use 100. You can try to reduce it by using PCA or principal component analysis. And then we should try to reduce it to as minimum as possible. With minimum features, we must be able to produce maximum accuracy.
Yeah,
That is the smartness.
using any dimensional reduction method.
Exactly.
Calculate theoretically.
Well,
Is there a formula to calculate?
Sorry?
Yeah, someone is speaking. Actually, you're not audible.
Yes.
Is there
Ma'am, your desktop is visible, ma'am. Maybe you can stop sharing.
Yeah, I'll stop sharing it.
Yeah.
Yes.
If there are no questions, then we can go for a vote of time session. Participants, any more questions?
there is any theoretical formula to calculate that?
Theoretical formula for?
Calculation of the number of input, output, and filters.
To decide on the number of input, output, and filters.
Actually, it is fully connected. In the last class, I told you if you have 4 input node and if there are 3 nodes in the first hidden layer, it is 3 into 4, 12. As simple as that. So likewise, you can extend it to any number of connections.
Thank you, madam.
Fine? Are you fine with the answer? Hello.
Dr. Pankaj?
Madam, whatever you are saying that agree with you, but there is some.
Pankaj, actually, you're not audible. Can you please use the chat box?
Okay.
There's one more question, ma'am. How implant instrument is fixed for patient in CNN?
The CNN is only a suggestive one, right? It unless otherwise AI is helping you in implant, then probably we can think of that. So as far as this AI is concerned, that will really help the dentist to do the diagnosis.
Dr. Pankaj, we are waiting for your question. Is there any formula to calculate if there are 100 extracted features? How many input-output nodes and filters are required?
Actually, you can just manage with this 100, which is the number of input nodes. And when you go for hidden layer, you have to specify how many hidden layers that you want to have. Right? So, and naturally, it's just a multiplication of one-to-one connection is there. You know what is how set is being formed, one-to-one or one-to-many. So if it is fully connected, we can just go for, there is no formula as such. It is simple mathematical calculation.
Okay, thank you, madam.
Thank you, sir.
Thank you, ma'am. Thank you so much for your very, very informative.
Thank you very much. Pleasure is mine to get connected to you all.
Yeah, we'll have a formal vote of thanks, ma'am.
Thank you. So I also record my thanks to dear coordinators of this event and the dear participants. We have got connected virtually. Let us thank the organizers for providing the platform for this connection. I thank the participants for your patience and presence throughout the session. Thank you, everyone, and wish you all the best. And I wish I express my wishes to the organizers to proceed further in the journey of RUSA 2.0 biomaterials.
Thank you, ma'am. A couple of minutes for a formal vote of thanks, ma'am, please.
Sure.
Good evening to one and all. It is not happy people who are thankful. It is thankful people who are not happy. I deem it a great honor to propose the vote of thanks to all who have helped us in making this 2 weeks workshop, day 11, such a resounding success. I thank our resource person, Dr. P. Shanmugavadivu ma'am, Professor and Head, Computer Science and Application, Gandhigram Rural Institute. Thank you, ma'am. Let us all meet on Monday at 4 p.m. with
Thank
another.
you.
Thank you, ma'am. Thank you so much, ma'am, for your time and your very informative session.
Thank you very much, ma'am.
Thank you.
Let us all meet on Monday at 4 p.m. with another interactive session on the topic Stochastic Biomodels by Dr. Uday Bhaskar sir, Senior Professor, Department of Mathematics, Vailtech, Rangarajan, Dr. Shakuntala, R&D Institute of Science and Technology, Avadi. Thank you all.
So good luck, everyone.
Thank
Stay
you, ma'am.
safe. Happy evening and happy Sunday. See you all
Yes, ma'am.
on some other platform, on some other occasion.
Yes, ma'am. Definitely.
Take care. Take care.
Thank you,
Bye.
ma'am.